Hello everyone, welcome back to another episode of All About Bridge Engineering. In today's episode, we will try to correlate types of portal frames which we have studied in our structural analysis textbooks and see its practical applications in bridges around us. And accordingly, this episode is also put in the playlist from books to reality.
The speciality of the structure that we have today is that the horizontal member of this portal frame is not monolithically built with the vertical members, but it is simply supported over the vertical members. So on your screens is a multi-span elevated road which crosses road at level 1 at some angle. The alignment of these two roads may have been designed in a way that they are not parallel to each other, but they do have good amount of live traffic running on them. Nevertheless, road at level 2 comprises of a series of superstructures, and the type of superstructure which is adopted in this is a girder plus deck type superstructure. This girder plus deck type superstructure is supported on multiple vertical supports. Most of these vertical supports comprise of a single pier with a cantilever pier cap, but one of these supports also has a portal frame in which there are two portal piers at the ends, and these are connected via horizontal portal pier cap, which in this case is not rigidly connected to the vertical portal piers but is simply supported. We will see a zoom section of the same, and before that let's understand why a portal frame was adopted at this location when on either side of this portal frame majority of the supports are single vertical pier with cantilever pier cap. Notice that in the beginning of this episode we discussed that both the alignments at the lower level and at the upper level cross each other at an angle, and both of these roads have a huge traffic volume. So in order to keep a single pier at the location of this portal frame, there are high chances that that pier should have been placed somewhere within the lower carriageway that would create hindrance to the upcoming traffic, which is definitely not a desirable scenario. Another option that could have been adopted is an eccentric location of the pier from the bottom carriageway, and in that case we would have a very large span of the cantilever pier cap, and that will be subjected to huge eccentric moments which will go all the way to the foundation as well. Hence, portal becomes the best choice in such scenarios, and that is the reason why we are seeing a portal frame at this very location. Now, depending upon the positioning of the superstructure over the portal cap, there are broadly two options that are widely adopted, and it's important to understand these two options. So let's discuss them one by one. In option number 1, it can be seen that the eye girders are supported over the yellow hashed pedestals which are positioned on top of the portal cap. In other words, the superstructure rests on top of the portal cap in option number 1. However, in option number 2, the girders are not supported on top of the portal cap, but they are supported somewhere within the portal cap through an arrangement of bracket or corbel within the portal cap. This bracket or corbel can either be placed at mid-height of the portal cap or at the lowermost point of the portal cap. Now let's investigate whether there are some differences in the design forces or design moments for the foundation in either of these options when all other dimensions are kept same or not through this animation. Please note that the bottom of portal piers in option 1 and in option 2 is intentionally kept at same level, and it can be seen with the help of this dashed line. Similarly, the bottom of portal caps in option 1 and in option 2 is also kept at the same level, which can be seen with this green dashed line. Now, as per minimum vertical clearance requirements of various design codes, the height of these portal piers is determined. And if I talk about Indian Road Congress or Indian Highway codes, this minimum vertical clearance is 5.5 meters, which is measured from top of the road at bottom level till the soffit of the deepest member of the portal. In this case, the member is portal cap. So from the soffit of portal cap to the top of varying surface of the road at lower level, this height is 5.5 meters. So let's say the centroid of superstructure, which is indicated by these red dots, lies at a lever arm of, let's say, 8 meters in option number 1. Now, why this is important? Because all horizontal forces acting on the superstructure will act through this red point, and typically the horizontal forces on superstructure are wind in transverse direction, wind in longitudinal direction, seismic forces in transverse and in longitudinal direction. Not only this, horizontal forces also act on live load or vehicles that move over the carriageway, Some typical examples of horizontal forces that act on live load are: in the transverse direction, wind force acts on live load, and if the alignment is curved in nature, then significant amount of centrifugal forces also act in the transverse direction. They are also part of horizontal forces acting on live load. In the longitudinal direction, we do have braking forces acting on vehicles. They also contribute to huge moments in the longitudinal direction. So let's say that the centroid of the live load is at least, let's say, 9 meters, just for an example in this very case. Contrary to this, all the horizontal forces acting on the superstructure girders in option number 2 will have a lever arm which will definitely be lesser than the lever arm in option number 1, for example less than 8 meters in this case. And also all the horizontal forces acting on live load in option number 2 will also have a lower lever arm. So by simple mathematics, just by keeping the superstructure girders within the portal cap, we can reduce the design moments that go for foundation design, because we have a reduced lever arm for same amount of design horizontal forces, whether on superstructure or on live load. Hence, by just keeping option number 2 for the portal structures, a huge reduction in design moments for foundation are achieved due to low lever arm for same amount of horizontal forces. This in turn saves concrete volume that goes into the foundation base slab and also saves reinforcement amount, and overall we may have an economical solution than option number 1. Please also try to understand, whenever an elevated road comes out of the ground level, huge amount of earthwork is done near the approach of the elevated road. With a reduced finished road level that can be obtained by option number 2, the amount of earthwork will be lesser. Not only this, the compaction effort required to compact the earth layers is also reduced, the fuel costs are reduced, and overall an economical solution is achieved. Now let's go back to our structure and see which option is adopted. It should be clear that option number 2 is adopted in this case, as the girders are placed within the portal cap and not on top of the portal cap. Also observe that there are caps at the ends of the portal cap, right between the portal piers and the cap, which means that this connection is not monolithic, and now we will see how it is obtained. By using a set of elastomeric bearings between the piers and the portal cap, we have ensured that monolithic connection is not formed in our structure today, and this helps in eliminating temperature forces associated with rigid portal frames, which is another huge force that is totally eliminated by provision of a simply supported portal cap. Let us now discuss the force flow associated with this structure. All the vertical reaction from the superstructure is transferred to this corbel that is attached at the bottom of the portal cap, and via corbel action, all these vertical horizontal forces are transferred at the ends of the portal cap onto the elastomeric bearings and finally to the pier. Also note that reaction on left pier is higher than reaction on the right pier, simply because left pier is more close to all these superstructure girders than the right pier. It's time to see this portal structure from side, and in the side view you can clearly see the supporting member over which the girders are placed, and the supporting member is flushed with the bottom of the portal cap. Not only this, a zoom section also clearly highlights the gap between this portal cap and the portal piers. Please also note that the portal piers have a bracket attachment on either side, similar to the bracket attachment on the portal cap. Between these two bracket attachments, we have elastomeric bearings. So this is how this structure is proportioned, and I hope this episode was insightful and helped you understand practical applications of portal frames in bridges around us. Some more episodes in the playlist from Books to Reality are developed, and they will be uploaded very soon on the channel, so stay tuned and do not miss future episodes. Thanks for watching, and I will see you in another episode very soon.